Right now, a piece of dust smaller than a grain of sand is moving 20 times faster than a bullet, aiming straight for a multi-billion-dollar spacecraft. A grain of dust, smaller than a fleck of ash, can strike like a bullet forged in the heart of a supernova. In the silent vacuum between worlds, speed transforms the insignificant into the catastrophic. There is no air to slow it, no friction to soften its path. Only motion, pure, relentless motion carrying ancient fragments of comets and shattered asteroids across the dark. When they meet a spacecraft, the encounter is less like a collision and more like an explosion. To imagine this, picture two ghosts passing through one another, except one ghost carries the energy of a lightning storm compressed into something no larger than a mote of pollen. The spacecraft, a fragile island of human ambition, drifts through this invisible storm. Each tiny particle becomes a test of survival, a question posed by the universe itself. How do you defend against something you can barely see, moving faster than anything your instincts were designed to comprehend? The challenge begins with scale. Space is vast beyond intuition, yet it is not empty. It is littered with remnants of cosmic creation and destruction, dust shed by ancient stars, debris left behind by collisions that occurred long before Earth had oceans. These particles are sparse, but the distances traveled by spacecraft are immense, turning improbability into inevitability. Over time, the chance of impact becomes certainty. The question is not if, but how often and how severe. At these velocities, conventional ideas of strength collapse. Steel, titanium, even advanced composites lose their reassuring solidity. When struck by a micrometeoroid, they do not simply dent, they vaporize locally, releasing bursts of plasma that ripple through the material like shockwaves through water. The impact creates a tiny crater, but the damage extends far beyond its edges, sending fractures racing outward in delicate, destructive patterns. A spacecraft is not a single wall, it is a layered system of electronics, life support, propulsion, and structure. A single breach in the wrong place can cascade into failure. So engineers have turned to paradox as a solution. Instead of building thicker walls, they build emptiness. Shields are designed not as barriers, but as traps, multiple layers separated by space, like a series of whispers rather than a single shout. When a particle strikes the outer layer, it shatters, dispersing its energy into a cloud of fragments and plasma. By the time this expanding spray reaches the inner layers, its fury has been diluted, its destructive potential softened. It is not stopped outright, but transformed, its lethal precision replaced with something more survivable. This approach reflects a deeper truth about the universe. Sometimes resistance is not about opposition, but about redirection. Energy cannot simply vanish. It must be managed, guided, diffused. Spacecraft shielding becomes an exercise in choreography, a dance with forces that cannot be defeated, only negotiated with. Yet even this elegant strategy has limits. As humanity dreams of traveling farther toward distant planets, icy moons, and perhaps one day the space between stars, the environment grows harsher. Regions filled with dense debris fields, or the faint but persistent drizzle of interstellar dust, present new challenges. Over long journeys, cumulative damage becomes a silent adversary. Each tiny impact is a note in a slow, grinding symphony of erosion, gradually wearing down the defenses designed to protect fragile human systems. There is also the problem of knowledge. We cannot map every particle, cannot predict every trajectory. Much of what threatens a spacecraft is effectively invisible, detectable only after it has already struck. This uncertainty forces engineers to design for the unknown, to prepare for conditions that may never occur or may occur in ways no simulation fully captures. It is a reminder that exploration is always an encounter with ignorance, a step into realms where data is incomplete and assumptions are tested by reality. And yet, within this challenge lies a profound connection to the cosmos. The very particles that threaten our machines are relics of cosmic history. Each micrometeoroid carries within it a story of star formation, of planetary collisions, of the slow, ceaseless evolution of matter across eons. To shield against them is not merely to defend against danger, but to engage with the universe at its most fundamental level. It is to acknowledge that space is not a void to be crossed, but an environment to be understood. In this sense, spacecraft shielding is more than an engineering problem. It is a reflection of humanity's attempt to coexist with the forces that shaped existence itself. Every layer of protection, every calculated gap, every material chosen with care, represents a dialogue between human ingenuity and cosmic reality. We do not conquer space. We adapt to it, learning its rules, respecting its extremes, and finding ways to survive within its vast, indifferent expanse. And somewhere, in the endless dark, another grain of dust is already on its way.